Okay, this last integral that you are asked to do, this was number 3. I skipped it in the previous video because it's a really tricky one. So this video might take a while, and I haven't worked it all out ahead of time. So let's see how this goes. All right, so I'm going to distribute the square root to both terms in my parentheses. So I'm going to do this whole square root times the 20 and the whole square root times the minus 2h. So this is 50 times the integral from 0 to 10 of 20 square roots of 100 minus h squared minus 2h times the square root of 100 minus h squared, all times dh. And then I can integrate term by term. I can integrate each of this and this separately. So rather than like write the antiderivative, because each of these is involved, I'm going to just separate the integrals. So this becomes 50 times. I'm going to integrate from 0 to 10, the 20 times the square root of 100 minus h squared dh. And then I'm going to subtract the integral, take the 2 out, h times the square root of 100 minus h squared dh. And that's all times 50. Okay, so I'm going to work on each of these integrals separately. And I'm going to do it on a separate page because each one takes a little bit of work. And then I'm going to come back here and try to replace this integral with a value. And oops, this is from 0 to 10. Replace this integral with a value. Oops, that's supposed to be a dh right there. dh. Okay, so each of these integrals is just some number. And so it's going to take a little bit of work to get it, but I'm going to do it on a different page. Okay, so the integral from 0 to 10 of the square root of 100 minus h squared dh. Okay, so I have something in my integrand of the form a squared minus h squared. So that's a trig substitution. I am going to let h be 10 sine theta, which means dh is 10 cosine theta d theta. And I'm going to make my substitution. I am just going to try to find an antiderivative, and after I convert back, I'll put the bounds on. Okay, so this becomes the integral. And instead of the square root of 100 minus h squared, it's going to be 100 minus 10 sine theta squared, which is 100 sine squared theta. And then instead of dh, I'm going to have 10 cosine theta d theta. If I factor out a 100, I can pull it right out of the integral. So this becomes the integral of 10 times the square root of 1 minus sine squared theta times 10 cosine theta d theta. Okay, so I've got two 10s here. I'm going to pull them out of the integral. So I have 100 times the integral. 1 minus sine squared is cosine squared, and I'm going to square root it. So that's cosine theta. So this is all cosine theta. So then I have cosine theta times cosine theta, which is cosine squared theta d theta. All right, so I need an antiderivative for cosine squared. This is not one of the ones that we know off the top of our heads. So I have to be tricky here. This is going to be 100 times the integral. I'm going to rewrite cosine squared theta using a trig identity. So it turns out that cosine squared theta d theta is equivalent to 1/2 plus 1/2 cosine 2 theta. So that's just a trig identity that I looked up, right? I said, oh, I think there's a trig identity for cosine squared. So I just Googled it and I found 1/2 plus 1/2 cosine 2 theta and said, oh, that might be helpful because now there's no squared. I can take an antiderivative of cosine, no problem. Okay, so this becomes 100 times, okay, so the antiderivative of 1/2 is theta. And then the antiderivative of cosine is sine. But because of the chain rule, it would be sine 2 theta times 2, but I have a 1/2 there. So 1/2. So I'm going to ignore the constant for the moment, and I'm going to say the antiderivative of cosine 2 theta is sine 2 theta, but then I'd have to divide by 2, sine 2 theta over 2. So that actually means I'm done. Sine 2 theta over 2. Okay, so let me check this. If I take the derivative of this, do I get this? So the derivative of sine 2 theta is cosine 2 theta times 2, which means this cancels to give me a 1. But I want that to be a 1/2. Okay, so the derivative of sine 2 theta is cosine 2 theta times 2. So I need something here so that when I multiply it by 2, I get a 1/2. So that would be a 1/4. And I'm going to evaluate that from nothing to nothing because I don't have any bounds right now. I'm going to convert it back to x's first. Go back up. Oh, h's. Okay. So if h is 10 sine theta, then I can solve for theta, and it is the arc sine of h over 2. So I'm going to h over 10. Okay, so I'm going to replace my thetas with arc sine h over 10 in my antiderivative times arc sine h over 10 plus 1/4 the sine of 2 times the arc sine of h over 10. Plus c, plus c. Okay. All right, so now that I have the antiderivative, I can do the integral that had the bounds on it. Okay, so my original integral was the integral from 0 to 10 of radical 100 minus h squared dh. So I'm going to jump to a new page. The integral from 0 to 10 of the square root of 100 minus h squared dh. I now have an antiderivative of this thing in terms of h. So this is scroll down, 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 down. 100 times the arc sine of h over 10. And so I need to evaluate this antiderivative from 0 to 10. Plus 1/4 the sine of 2 times the arc sine. All evaluated from 0 to 10. Okay, so I'm going to let my calculator help me here. A lot of this I can do in my head. Okay, so if I plug in a 10, plug in a 10. 10 over 10 is 1, and the arcsine of 1, so you're looking for a place in the unit circle that has a sine value of 1. That happens at pi over 2. And then, let's see, I'm going to do it again over here. So arcsine of 1 is pi over 2 times 2 is pi. The sine of pi is 0. A fourth times 0 is 0. Okay, if I plug in zeros now, the arcsine of 0, place on the unit circle where the sine is 0 is 0. So the arcsine of 0 is 0 times 2 is 0. The sine of 0 is 0 times a fourth is 0. So this ends up just being 100 pi over 2, or 50 pi. And that is not the answer to the question. This was a small piece of a much larger integral. So I'm going to go back and back. This green underline, I believe, is 50 pi. Okay, before I move on and start trying to calculate the other integral, I want to check. Does this green integral from 0 to 10 of radical 100 minus h squared dh, does that equal 50 pi? So I'm just going to have my calculator check for me. So I'm going to go math 9, 0 to 10, square root of 1. Oops. Second square root 100 minus x squared dx. 78.53. Oh, I don't think that's 50 pi. Let's see, 50 pi is 157. I think I'm off by a factor of 2, right? If I divide this by 2, yeah, then I'd be right. So I'm missing a factor of 2 somewhere in the work that I did to get this 50 pi. So let's see if I can find that. All right, I think what happened was right here, this 1/2. When I integrate that, I should have gotten 1/2 theta and not just theta. 1/2 theta. All right, and then let me double check this other piece of my integral here too. So the derivative of sine 2 theta is cosine 2 theta times 2. So if I have a 1/4 there, then when I multiply by 2, I will get the 1/2. So I think that 1/2, I'm hoping that that's going to fix it. So I have to put a 1/2 right here. And then next page, I've got a 1/2 right here, which means I have a 1/2 right here. And that will work because everything else has a 0. So this comes out to 25 pi. Okay, so go back to my original integral. Now I have found my mistake. This is not 50 pi, it's 25 pi. Okay, my next integral, I'm going to do this on a separate slide as well. This one is not quite as hard. I think a u substitution will work because the derivative of h squared is 2h, so I have a function whose derivative also shows up. So I'm going to integrate this using u substitution. So I want the integral from 0 to 10 of h times the square root of 100 minus h squared dh. Okay, so I'm going to work on the antiderivative. And once I have the antiderivative, I can plug in the bounds. So I'm going to let u be 100 minus h squared. So du dh is negative 2h. So dH is du over negative 2h. So I've got the integral of h times u to the 1/2. And instead of dH, I have du over negative 2h. And the h's cancel. So I have the negative 1/2. Pull it out of the integral. The integral of u to the 1/2 du. The antiderivative of u to the 1/2 is u to the 3/2 times 2/3. Twos cancel, and I get negative 1/3 u to the 3/2 plus c. And I'm going to replace the u with 100 minus h squared. Okay, so now that I have an antiderivative, I can do the definite integral. So I wanted to integrate from 0 to 10. Okay, that was my original integral that I'm trying to evaluate. I now know its antiderivative. So this is going to be negative 1/3 times 100 minus h squared to the 3/2 evaluated from 0 to 10. Okay, so plug in a 10. So h squared, 10 squared is 100. 100 minus 100 is 0. 0 to the 3/2 is 0 times negative 1/3 is 0. It's 0 when you plug in 10. Minus, plug in 0. Okay, so if I plug in a 0, 0 squared is 0. 100 minus 0 is 100. When I square root 100, I get 10, and then I'm going to cube it, and I get 1,000. So I get negative 10,000 thirds. So that comes out to positive 10,000 thirds. So again, this is a small piece of a larger problem. I'm going to go back and replace the integral I just evaluated with 10,000 thirds. And then before I go ahead and move forwards, I want to check that with my calculator. Math 9, I'm going to integrate from 0 to 10 x times the square root of 100 minus x squared dx. Oh, it's 100 minus x squared, right? There we go. $333 and a third. That is the same thing as 10,000 thirds. Good. Oh, no, it's 1,000 thirds. I'm off by a factor of 10. Okay, let's figure out where that factor of 10 came from. Okay, here's all the work I did to get 10,000 thirds. Oh yeah, I see it. Okay, so when I was evaluating, I was putting 0 in for h. So I get 100 in the parentheses. Square root of 100, because that's the 2, square root of 100 is 10, and then 10 cubed is 1,000, not 10,000. So 1,000 thirds. Okay, so now I just have to plug all this into a calculator. So I have 50 times 20 times 25 pi minus 2 times 1,000 thirds. So 20 times 25 pi, that's 500 pi. Right, because 10 times 25 pi is 250 pi times 2 is 500 pi minus 2,000 thirds. All right, now it's time to just type all this into a calculator. .500 pi minus 2,000 thirds. I have to multiply all that times 50. And I get 45,206.48, which is the answer we got when we integrated using the calculator. 45,206.48.